Okay.
Good afternoon all. Now we'll discuss about the design thinking based satellite and space communication. How the error correction is used in this particular communication. We'll discuss with the design thinking approach. So there will be 5 stages in this. So according to the 5 stages, first everyone prepare that. Then we'll start the discussion based on it. Design thinking will be having 5 stages in it. First we'll finding out the problem based on the customer needs. So that we have to find the problem statement first. Then the 5 stages are empathy, define, ideate, prototype and testing. In empathy part, we'll define what are all the problem statement and will be taking all the problem statements at a time and will be finding a solution. The best one solution, that is called empathy. Defining that empathy part in a detailed manner based on how we are going to design this particular using Aurora software like that. Ideate is bringing some extra ideas to the particular problem statement as we discussed in the empathy and define stage. The 4th stage is prototyping. In prototyping, we'll be combining all the 3 stages with help of what exactly we are going to find out here using hardware or software. So in prototype we'll be finding what hardware or software whether it is. Then in testing we'll be concluding what we are going to test, whether using the hardware components testing or software. So by concluding the product will be ready by using this testing. So let us start one by one.
So I'm going to speak about the empathy part. So in practical use we know that Mars exploratory rover mission was held. It was done by NASA in the year 2003. It was actually used for reliable communication between the space and Earth. It used to send scientific data or images and all from the space to the Earth. But it had equal amount of challenges also. Firstly, the long distance was the main challenge. The distance between Earth and Mars was very long. So the signals before reaching the Earth itself, they started getting weak. And the second issue was noise and interference. There were many noise signals and interference in the space. So conveying the actual data was harder. And latency, mainly because of distance, the signals that reached the Earth were delayed for approximately 20 minutes. And through the communication process also in space, there were harsh environment. Like due to solar rays or cosmic rays, the signals were being affected. And then the next point is bandwidth. So when we come to bandwidth, in space they use only a particular level of bandwidth. So the signals weren't efficient that way. So all these challenges were faced and the communication wasn't actually reliable. So that's why we are developing the program.
I'm going to talk about the define encoding techniques, turbo code, LDPC and BCH. Turbo codes used for telemetry data and LDPC codes are for high efficiency error correction and BCH used for the uplink commands. The data transmission is held first. Data is divided into packets. It is encoded using the turbo code technique and using the deep space technology it is decoded. And using the algorithm, error is auto-corrected. The outcome will be transmission of over 100,000 images and scientific data packets with minimal data loss.
So I'm going to talk about the ideate. So there are 4 techniques called Reed-Solomon codes, turbo codes, low-density parity chip code, and convolutional code. So firstly about the Reed-Solomon code, it is used to correct the noisy errors and which is applied in the satellite communication.
And secondly about the turbo codes, it provides near optimal performance and widely used in telemetry and interplanetary missions. And thirdly about the LDPC code, and it is efficient for low latency systems and applied in the Earth observation systems. So finally about the convolution codes, it is used to correct the real-time errors and applied in the satellite uplinks and downlinks.
Now I'm going to talk about prototyping error control code. Reliability: reduce the impact of noise and interference, ensures high data integrity. Efficiency: optimize bandwidth usage by reducing retransmissions and ensures low power operations. And scalability: supports diverse applications from real-time telemetry to multimedia broadcasting.
So let me say the testing part. So in testing we implement in satellite, GPS and space probes. So in satellite television broadcasting, Reed Solomon and LDPC codes ensure error-free video and audio transmission. So in GPS navigation system, ECC ensures that errors are caused by atmospheric interference and multi-path effects. So in space probes, error correction ensures reliable scientific data from deep path missions.